Yes. So last slide, we have been discussed about modern thermal power plant. Here you can see the typical coal-fired thermal power station. Generally, a steam power plant converts the chemical energy of the fossil fuels like coal, oil or gas into the mechanical or electrical energy. Here you can see the components of thermal power stations like boilers, in which we have superheater, reheater, economizer, air heater, steam turbine, generator, condenser, cooling towers. There is a circulating water pump, boiler feed pump, ash precipitator, coal mills, water treatment plants, forced draught systems, control rooms, and switchyards. So many things are it is available in the thermal power stations. For this for this um, uh, better thermal power station, we need the better designing. For this better designing, we need some essential requirements like reliability, minimum capital cost, minimum operating and maintenance cost, capacity to meet the peak load efficiency, low cost of energy supply to the consumers, reserve capacity of meet furnace demand, and mainly the simplicity of design, use of automobile equipment and extensibility. So a lot of things we record for better designing of this thermal power stations. Next, the site selection. It is also one of the important phenomena for better designing. The main things for this site selection is availability of raw material and the nature of the land, cost of land, availability of water, and the transport facilities, ash disposal facilities, availability of laborers requirements, size of the plant, load center, public problems, and the future extensions. These are all the things are required for better site selections. Let's see what is the boiler. Boiler may be defined as a closed vessel in which steam is produced from water by combustion of fuels. Here we have done what is the steam, why we are going to generate the steams, what is the purpose, right? Let's see here for generating power in steam engine or steam turbines, and second in the textile industries for sizing and bleaching, etc., and many other industries like sugar mills, chemical industries need for steam, and third for heating the building in cold weather and for producing hot water for hot water supply. This is the main purpose for steam generator. Yes. Here there is a type of boilers, 5-2 boilers and water tube boilers. The 5-2 boilers, if the hot gases is passed through the tubes and the water is circulated around the tubes, it is called 5-2 boilers. Example, Cochrane boilers and locomotive boilers. In water tube boilers, the water is circulated through the large number of tubes and the hot gases, the flue gases passes around the tubes. So it is called the water tube boilers. Example, Babcock and the Wilcox boilers. And see the low pressure boiler and high pressure boilers. The low pressure boiler means here it is the pressure will be maintained at 3.5 to 10 bars for Cochrane boilers. In high pressure boiler, here the maintained up to 25 bars and the temperature will be 500 degrees Celsius. Example, Babcock and Wilcox boilers. Next, what is the fluidized bed combustion systems? It is the one of the main combustion system when compared with other systems. So here the fluidized system bed may be defined as the bed of solid particles behaving as a fluid. Okay, behaving as a fluid. The principle of FBC system is the gas, here a gas is passed through a packed bed of finely divided solid particles, right? Finely divided into finely divided solid particles. It experiences a pressure drop. It experiences a pressure drop across the bed. So at the low gas velocities, this pressure drop is small and does not disturb the particle, okay, at this lower velocity. But if the gas velocity is increased, what happened? A stage is reached when particles are suspended in the gas stream and the packed bed becomes a fluidized bed. This is the important points of the fluidized bed combustion systems. Right? Here, figure show the arrangements of FBC systems. On this distributor plate here, on this distributor plate, okay, here the distributor plate is here. Okay, the fuel and inert material like dolomite, and from its bottom air is supplied. From its bottom here the air is supplied. Okay, the high velocity of air, what happened, keeps the solid feed material, okay, solid feed materials in the suspending condition during the burning. Okay, air keeps the solid feed material in suspending condition during the burning conditions. What happened, the generated heat is rapidly transferred to the water, passes through the tubes immersed in the bed. So here generated steam is coming out. Okay, what happened, the generated steam is coming out. Okay, then during the burning time the sulfur dioxide formed. During the burning time, what happened, the sulfur dioxide is formed and it is absorbed by the dolomite. So this is the main purpose for using the dolomite and prevents its escape, and also prevents its escape, right, with the exhaust gases. So when using fluidized bed combustion systems, we can avoid the pollution free. We can avoid the pollution. So this is the main purpose for using the fluidized bed combustion systems. Right. Let's see the advantages of the fluidized bed combustion systems. The unit size and the capital cost. What happened? Capital costs are here reduced, and the low combustion temperature required. Maybe 800 to 950 degrees Celsius temperature is required, and the combustion temperature are low. The falling and the corrosion of the tubes is reduced considerably. What happened? It's reduced considerably. Pollution control and combustion of high sulfur coal is possible. Pollution is controlled and the combustion of high sulfur coal is possible. This is main advantage of this system. Okay, the next one. This is the advantages of FBC boilers, which I had, which I already discussed. What do you call turbines? Let's see what is the turbines. Here we have impulse turbine and reaction turbines. Let's see what is the function of the turbine. Here the steam, the high pressure superheated steam, because high pressure superheated steam will be entered here, and here it will be impinging on the turbine blades. Okay, at higher pressure, what happened, after impinging there is a pressure drop of superheated steam. It will be come down to the condenser. Okay, it will be come down to the condenser. After impact with the turbine blades, the turbine blade will be rotated. What happened? Turbine blade will be rotated. This turbine exhaust will be coupled with the generator. What happened? The generator will be producing electricity. This is the working function of turbine. And next, this is the photograph view of example view of turbines. Okay, impulse turbine. The working function of impulse turbine is it runs by the impulse of steam. and the nozzle directs the stream. Okay, here the nozzle will direct the stream on the curved blades. Here you can see the curved blades, which causes them to rotate. It will be rotated. Due to this portion, the blade will be rotated. The blades are the shape like the buckets. Here it is shaped like buckets. In reaction turbine, working principle is it has no nozzles, and the two rows of the movable blades are separated by one row of fixed blades. The fixed blades are attached to the casing and act as a nozzle. Here it is act as a act as a nozzle. Blades are like a wings of a plane. Difference between impulse and reaction turbine. The main difference between impulse and reaction turbines are here it is. I have shown the steam in impulse turbine. The steam flows through the nozzle and impinges on the moving blades. Okay, it is impinging on the moving blades. But in case of reaction turbine, the steam first flows through the guide mechanism and then through the moving blades. Right? The second one, the steam impinges on the buckets with the kinetic energy. In reaction turbine, the steam glides over the moving vanes with pressure and kinetic energy. And the third one, the steam may or may not be admitted over the whole circumference. In reaction turbine, the steam pressure is reduced during its flow through the moving blades. In impulse turbine, the blades are symmetrical. Here it is not symmetrical. This is the main difference between impulse and reaction turbines. Let's see what is the condenser. Here the condenser is a device in which the steam is condensed to water at a pressure less than the atmosphere. And the condensation can be done by removing heat from the engine from the exhaust stream using circulating cooling water. During condensation time, the working substance changes its phase from vapor to liquid and rejects the latent heat to the water. The exhaust pressure in the condenser is maintained nearly 7 to 8 kPa, which corresponds to the condensate temperature of nearly 330 Kelvin. The main function of the condenser is to reduce the turbine exhaust pressure so as to increase the specific output and hence increasing the plant efficiency and decreasing the specific steam consumptions. And as well as it will condense the exhaust steam from the turbine and reuse it as a pure feed water in the boiler. Thus only makeup water is required to compensate loss of water. Also enables the removal of air and then non-condensable gases from the steam. Hence improve the heat transfer rate. This is the main function of the condenser. The main elements of the condenser is condenser, air extracting pump, condensate extraction pump, cooling water recirculating pump, hot well, cooling tower, makeup water pump, and boiler feed pump. There is a 3 classifications according to the type of flow: parallel flow, counter flow, and cross flow. And according to the cooling action, there are several types like jet condenser, mixing type, low level parallel flow jet condenser, low level counter flow jet condenser, high level jet condenser, ejector jet condenser, and surface condenser or non-mixing type, it having downflow, center flow, inverted flow, regenerative types. Let's see surface condenser.